Now, as you recall from previous lessons when we were in Chapter 2, we knew that if we had our equation in the y equals, we could go to the table to find output values. So if I do second graph, then I have my output values, and here I wanted the model, and it was stated in the problem or in the lesson what these values are. And so if I go to 11, I see this is 9.82. Likewise, if I was looking at using the 83, again, second graph, which is our table, and I can just scroll down to number 11. And again, we have 9.82, which was the information that was given in this particular problem at the very beginning, 9.82. So we can go through and find each one of these values and compare them with the actual value. Remember, regression is not going to give us the actual outputs, but it's going to give us a very close model. So the other thing we would want to do is if we want to know something that's happening, so if we suppose that we know that the output for this particular problem is going to be, so if we want the output to be somewhere, let's say that we want to know what the temperature is at 8, when there's 8 parts per million. Here we knew from before that the trout can live at 6 parts per million, so maybe we should find that, what that temperature is going to be. So we want this to be a 6, so that's our output. And now we have to adjust our window, because we're going to find the point of intersection. And so our inputs are from 11 to 31. So again, I'm going to go a little bit bigger than all that. So I'm going to go, so from 0 to, let's go to 40. We can count by 5s, because again, this is just our graph paper, so we want to make sure we capture everything. We need to go make sure we go as low as 6, so we can go from 0 up through 15 is our outputs. And again, the process would be the same on the 83, and I'm going to count that by, let's count by 3s. And then when I graph, here is our model. Again, it's decreasing because we knew this to be a negative slope from before. And there's our line 6, or 6 parts per million, second trace, which is our calculate function, number 5 for intersect. And again, this is a review from what we did in the Chapter 2, the very end of our Chapter 2 work. And we're going to move this over to approximately where the intersection point looks to be, and then hit the enter key 3 times. 1, 2, 3, and there's our intersection. So we know the trout need a minimum of 6 parts per million. That means that the temperature is 31.76 degrees Celsius. So again, the intersection is a point, so it's the input and the output.